Hi everyone, and welcome to today's Chemistry Daily Booster. This is number 15 and the final one in the series for Paper 1 Chemistry. It is an advanced information listed topic for those of you doing the foundation chemistry. Not explicitly listed on the higher tier, but as we found out from the biology paper, that doesn't mean it's not coming up. So, what we're looking at is electrolysis. Now, electrolysis isn't as bad as some of you like to make out. It's actually quite a straightforward process when you get a couple of bits in your brains. So the first thing to get sorted is what we mean by the phrase electrolysis. And quite simply, if we split that up into the two parts, electricity, and lysis, splitting. So what we actually find here is we are splitting something using electricity. That is literally what electrolysis means, splitting with electricity. Now, in order to do this, what we need are basically three key things. We need two electrodes. Now, those electrodes are actually going to be either metal or graphite because they're going to conduct electricity first of all. We need this stuff called the electrolyte. Now, the electrolyte is a compound in the liquid state or it's a solution. And the whole purpose of the electrolyte is it contains mobile ions and therefore conducts electricity between the two electrodes. And finally, we need an electrical supply, usually in the form of a power pack. The next bit to get straight in your minds is the names of certain things. So we need to know the cathode is the negative electrode. Here is my lovely picture of my very negative looking cat for you. So remember, cathode is negative. The anode is the positive electrode there. So cathode negative, anode positive. If you can remember that, that's a really good start with electrolysis. Now, what actually happens if we look at our little diagram down here at the bottom? When the power supply is turned on, then what we're going to find is there's our cathode, so we've got negative on the left-hand side, positive on the right, so there's the anode. So our electrolyte is made up of these positive and negative ions. And so as the electricity is turned on and flows through the electrolyte, what's going to happen is the positive ions are attracted to the cathode, the negative electrode. So what we find is as those positive ions reach the cathode, then they are going to gain electrons, and that means they become neutral atoms. The negative ions are going to do the same thing by going to the anode. So negative ions are attracted to the oppositely charged anode, which is positive, and when they get there, they're going to lose electrons. So if it's negative, it loses electrons. If it's a positive ion, it gains electrons. And again, the end result is it becomes a neutral atom. So in reality, what we're doing here is it's almost like using electricity to sort the positive and the negative ions and then discharge them at the electrodes. So please be aware of the names of those ions. So cation is the positive ion. You might think, well, that's stupid. Why is it not called an anion at that point? The reason is because the positive ions are attracted to the cathode, then we call them cations. So cathode is the negative electrode, it attracts the positive ions, the cations. Anode is the positive electrode, it attracts the negative ions, called the anions. So what we find here then is that we've just got a couple of terms that we need to use. If you can't remember cation and anion, then most times you will be able to get away with saying positive ion, negative ion. Just remember, opposites attract. So if you know the cathode is negative, positive ions are attracted there. Anode is positive, the negative ions are attracted there. Another word they do like at this point is this one here, inert. If something is inert, it's unreactive, so it remains unchanged. So what we find is the electrodes we usually use as far as electrolysis goes, they tend to be graphite or unreactive metals. We do need to be able to predict what we make in different scenarios using electrolysis. So we're going to start off with a relatively simple thing here, a binary ionic compound. So if we break that down, bi means 2. So realistically, we are looking at a 2-ion compound. So a compound made of 2 different ions. Giving you the example here of lead bromide, PbBr2. So what we're going to see here then is lead, Pb, is going to be positive ions. It's a metal, always forms positive ions. Now, because they're positive, they will be attracted to our negative electrode, the cathode. When they arrive, it's Pb2+, and that means they're going to gain 2 electrons to become lead atoms. So there's our half equation for it. If we consider what happens at the anode, our positive electrode, that attracts the negative ions, bromide ions in this case. So we're going to have our 2 bromide ions travelling over to the anode, and when they arrive they will lose those electrons to become bromine, Br2. Why does it go around as Br2? Because it is in group 7, it's a halogen, and remember all of them are diatomic, so they always have the little 2. If you don't put that in, balancing always goes wrong, you get the whole thing wrong. So remember, halogens always diatomic. Now, what we actually find is, as we said earlier, those ions are discharged when they reach the electrodes. Because of that, we end up with this smaller or lower concentration of ions close to the electrodes. So because of that, we end up with ions moving to replace them by diffusion, because we've set up that concentration gradient. So it goes from high to low, moving the other ions to the electrodes themselves, and then they get discharged. So it keeps going the whole time that obviously this is switched on. It's worth remembering here that this is only going to work, the whole process of electrolysis will only work if they are molten or they're a solution. So we won't find electrolysis happens when they're solids because ions are not free to move. That brings us very nicely onto the idea of solutions then. If we're talking about something as a solution, remember it will have our little state symbol AQ, aqueous solution. Then that means it is dissolved in water. So water itself is partially ionized. So here is our little equation for what happens with water. We've got our reversible reaction sign here, half an arrow right, half an arrow left, and our water molecule is split into hydrogen ions and hydroxide ions. So when we talk about solutions, we not only have the ones of the water, so hydrogen ions and hydroxide ions, but we will also have the ions from whatever is dissolved in there. So do remember that, because that means we're going to get competition then at the electrode, because only one ion can be discharged at each electrode. How do we know what's formed then in that situation? Well, there are 2 rules to learn. So here's our first rule for the cathode. Okay, so at the cathode, we will produce hydrogen unless a less reactive metal is present. So this is where we're going to learn these 4 metals at the bottom: copper, silver, gold, and platinum. So basically, at the cathode, we will form hydrogen unless copper, silver, gold, or platinum are present. If any of those are there, they form. If we then consider our anode, the positive electrode, then the rule is oxygen forms unless we have group 7 elements present. Group 7 are the halogens. Remember, you've got a periodic table, so if in doubt, look at that one, look at group 7, second column in from the right hand side. If it's there, that will form. If it's not anywhere there, it's oxygen that will be made there. So quite straightforward to remember. Cathode makes hydrogen unless we have copper, silver, gold, or platinum, in which case that one forms. And the anode produces oxygen unless something from group 7 is present. We can also use this whole idea of electrolysis in a process called electroplating. Now, the whole purpose of electroplating is to basically transfer metal onto the surface of something else. So because of that, we are going to use what we refer to as non-inert electrodes. This means they are going to react. So what we find then, the cathode is going to be the object we want to coat with our metal. The anode is the metal we want to coat it with. And the electrolyte is a solution that contains ions of the metal we are using to do the coating. So we still have those same bits, but slightly different. Object we want to coat is the cathode, the metal we want to coat it with is the anode, and the electrolyte has to contain the ions of that coating metal for it to work. Similar process, turn the power on. What happens is those metal ions from the electrolyte are discharged on the surface of the object, and then in order to replace those discharged metal ions, then our anode is going to start to break down and release those ions. As a result, the anode is eventually used up and needs replacing. Here's an example then. If we want to do some silver plating, then at our anode, which would be made of silver, there's our silver, Ag, we're going to form silver ions. So as a result, we've got Ag+, and we've released an electron to form our silver ion. When we get to the cathode, and we're actually doing the plating part, those silver ions gain an electron to become silver atoms. So it's quite straightforward what's happening here. It's always about gaining or losing electrons. The one other process they could ask us about is copper. Now, we will use electrolysis in terms of purifying copper, because when we extract it from its ores, then it's not always pure. There are other bits in there that mean it's not quite as good at conducting electricity, etc. So we want pure copper. And the way that we do this is we use electrolysis. So we have the impure copper is our anode. We have a cathode made of pure copper, and then we use copper sulfate solution as the electrolyte. So we've got a little setup here, so we can see impure copper anode, pure copper cathode, and then our copper sulfate solution between them. When we turn on the power, what's going to happen is the anode is going to lose copper atoms, because they're going to be travelling through the electrolyte to the cathode. That means our anode is going to decrease in mass, and the cathode is going to increase in mass, because those copper atoms that we've lost from the anode are going to be deposited on the cathode. Anything else that's not our copper is basically going to accumulate down at the bottom of the tank here as sludge. So that means all those impurities just drop to the bottom of the tank, and all we have on the cathode is pure copper. Final thing to do for today then is to have a go at the quiz, check how well you've understood the process of electrolysis. If there are still bits you're not 100% certain on, then of course use the videos on the main channel, use your revision guides, use your classwork. Just make sure you do go over it, particularly if you are doing the foundation paper, because we are guaranteed that those questions are coming up. How many marks? TBC, but we know it's coming up. On the higher tier paper, I would still say, based on that biology, highly likely to still have at least some marks on this, because it is an entire section. So make sure we do understand it before we go in. Don't forget to join us for the live stream the night before your actual chemistry exam as well. It will be starting at 6 p.m.